So I'd like to start with just a definition of psychoneuroimmunology, or PNI, as well as just a little history of where this area of research emerged from. So first, psychoneuroimmunology is really the study of the effect of the brain or mind on health and resistance to disease, aka the immune system. And in this line of work, we're really looking at the interactions between three different systems: the nervous system, the endocrine system, or what regulates our hormones, and so including things that we've talked about so far, like cortisol and epinephrine and norepinephrine, and then how these interact with the nervous system, right? So we've talked a lot, with the immune system, and this is really what we're adding here, right? We've talked already in this class about the endocrine system interacting with the nervous system in relation to stress, and now we're going to add to this immune system piece. And so this is really what we're going to get into in this lecture. And so just to put this differently, it's the study of the interactions between the central nervous system, and that really includes also parts of the endocrine system, because that is part of what the nervous system uses to communicate with the immune system, and so how that CNS interacts with the immune system using these three different components. So that's psychoneuroimmunology. And so where this emerged from is from some really fascinating and classic studies by Adder and Cohn. And what they did in this work is they were looking at rats that had a genetic predisposition to get lupus. And lupus is an autoimmune disorder. And as we're going to learn later in this lecture, an autoimmune disorder is a disorder where your immune system is overactive and starts to attack the self, and so it starts to attack tissues of the organism's body. And so obviously this is a bad thing. This makes you very sick. There's lots of different types of autoimmune disorders, and lupus is one of them. And so what they did with these rats is they wanted to see could they condition the immune system in the way that we condition other physiological responses in the body, right? You've probably learned about Pavlov and his dog, and they conditioned the dog to salivate at the ring of the bell. This is a similar idea, but they wanted to see if they could condition the immune response to act like it would in the presence of a drug when that drug was not really there. Right, so in the same way that the dog would drool even when the food wasn't there, if the bell rang, they wanted to do that same type of paradigm here. And so I'll show you a little bit more what that looked like. And from this work, they indeed found, and this was a huge discovery at the time, that the mind can affect the ability to fight disease, that through this conditioned response, it seems like there are psychological factors that are impacting the immune system. And this was really the first demonstration of that. And at the time, these researchers were really scorned. This seemed really ridiculous to people to think that the immune system was just a physiological process and it would not be impacted by things like psychological stress or other psychological factors like conditioning and pairing with other stimuli. But so what they did in this study is these rats were prone to autoimmune disorders, and so they initially they conditioned them by pairing saccharin-laced water or sugar water. This is the conditioned stimulus with a drug that is an immunosuppressant drug, and this is the unconditioned stimulus. Right? You don't need to condition the body to respond to that. It's going to respond to that because it's an active ingredient drug. It's going to evoke a response from the immune system, in this case, just to suppress that. So they give them this drug in the water over and over again, and so they pair them across multiple trials over time, and then later, for some of the rats, they take that drug out of the water and they just give them the sugar water. And what they found is that after this repeated pairings, rats that were just given the sugar water showed the same immunosuppressant response as rats that were continuing to get that drug. And so essentially, they're now showing an active treatment effect from a placebo pill. And so this, again, is indicating that there's something psychological, or at least through the mind, that's going on here. And so this is the first demonstration that the immune system interacts with the brain in some way. And so this led to one of the sort of early ways of thinking about stress in the immune system and the interactions between the central nervous system and the endocrine system and immunity. And so this is the old model. This is still often taught. You can still see figures like this in textbooks, but what this is showing, you might recognize many of these pieces from our stress lecture, right? We had a stressor occurs, and there's two different axes in the sympathetic nervous system that control short and long-term stress responses. We've got the SAM axis, the sympathetic adrenal medullary axis, and the HPA axis, or the hypothalamic pituitary axis. And this is the one that releases cortisol over the long term. Remember that. And so this is here you can see the endocrine system working. Right, we've got endocrine glands on the adrenal cortex, and this is interacting with the nervous system. And same with the SAM axis, the SAM axis. We've got the adrenal medulla, and that's releasing other hormones like catecholamines, and so these are also impacting the immune system. And so this model is still true, right? So that things can go from top down. The mind can impact the release of stress hormones. But what we know now is that also these things can feed back in the other direction, that the activity of our immune system can impact our psychological experiences as well. And so now we look at this in both directions. So really the new model, we would look at it like something like this, where there's interactions between all of these processes. So this is a bidirectional view of psychoneuroimmunology. So here we have the nervous system, the immune system, and the endocrine system, and they're all communicating with each other. And they're doing so with some different chemical messengers, but we've got the endocrine system talking to the nervous system through neurotransmitters and hormones. The endocrine system also talks directly to the immune system through cytokines. We're going to learn about a couple in this lecture, the interleukins, but those are really chemical messengers for the endocrine system to talk to the immune system. It also uses hormones to do that as well. And then the immune system can talk to the nervous system with neurotransmitters and cytokines. And so all of these three systems can interact with one another and feedback. And so outcomes and things that people are interested in who do psychoneuroimmunology work are looking at how immune system processes like inflammation and allergies can impact insomnia and depression, as well as vice versa. And so again, we can look at all these different interactions between these factors. And so we understand the body and its interactions with the mind as a very complex bidirectional system now. I'm going to pause there, and then we'll come back and talk more about how the immune system works, since this is really the piece that we're adding to this model here. So I'll see you in the next video.